We're going to be doing sequences and series. So let's say I gave you an a sub n formula here. Let's say I gave you something gross like n squared over n factorial. Something kind of nasty. Exclamation points of factorial. Have you guys never seen that before?
I don't know.
You've probably seen a factorial before. Maybe not. Alright, do we need to start with factorials then?
What does it mean though? I've heard of it, but I don't know.
Let's say we want to evaluate 3 factorial. Now most of your calculators actually have a factorial on there. This guy is 6. This guy is factorial means you multiply the starting number, which is 3, by one less number every time. So 3 multiplied by 2 multiplied by 1. That's a factorial.
So if we had 4 factorial, it's 4 times 3.
So 4 factorial equals 4 times 3 times 2 times 1. That's 4 factorial. Now if you multiply that together, this guy is 6. This guy is 24. 5 factorial would equal 5 times 4 times 3 times 2 times 1. So it would be 120. Is that right?
Yeah.
5 times 24. Sounds pretty good to me. All right. 6 factorial would equal 6 times 5 times 4 times 3 times 2 times 1. 720. Cool. So there's a pattern here. If we went up above that, 2 factorial would equal 2 times 1, which is 2.
1 factorial.
1 factorial equals 1 times, well, nothing, just 1. Believe it or not, I hate to do this to you guys, 0 factorial equals 1. It's kind of the exception to the pattern, exception to the rule. There's a big proof for that. We're going to save the proofs for math induction later. Okay? But there's a kind of a fancy proof for why 0 factorial actually equals 1. What's up?
I need to write that down. A big chart.
You don't have to write anything down. This is a free country. You can do whatever you want. So now, as you look at this, today's going to be a little more challenging, I think, because they're going to have you write your own. They're going to have you write your own apparent nth term. So they're going to have you write your a sub n equation. Okay. The hard part is they're going to mix all of them together, and you're going to have to identify what the different kinds are. I've given you 2 really big ones. Okay. Another common one that we'll see is this factorial concept right here, which is, if you notice, if you go from 1 to 2, you're adding 1 there. If you go from 2 to 4, you're adding 4. So we know it's not arithmetic. We're not adding the same term every time. Okay. This one, though, if I multiply 1, I multiply by 2. Then I multiply by 3, then I multiply by 4. So if you're multiplying by a number that's bigger, that's going to be a factorial type pattern that we're going to be looking at. Okay. Also, if you notice, look how fast those numbers get so big so fast, right? So 7 factorial is huge. Okay. So if I want to write, let's say my summation equation, let's say my nth term equation right here is n squared over n factorial, and I want to find the first 5 terms of this guy. Right. So the first 5 terms, a sub 1, you would plug in a 1, be 1 squared over 1 factorial. Which would be 1 over 1, which is 1. The second term, you once again would just plug in a 2. So it would be 2 squared over 2 factorial, which would be 4 over 2, which is 2. A sub 3, the third term, plug in a 3, would be 3 squared divided by 3 factorial. So that would be 9 over 6, which would be 3 over 2. Right? Everybody see that?
Yes.
Okay. If you want to find the fourth term, a sub 4 would be 4 squared over 4 factorial. So that's 4 squared is 16, and then divided by 4 factorial is going to be 24. So 16 24s, which we can reduce to. You know what that reduces to? Okay. 2/3. Sounds pretty good. A sub 5 would be 5 squared over 5 factorial, which is 25 over 5 factorial is 120. Let's see, 5 goes into both those, so that would be 5 over, what times 5 go to 120? 24, I think. So 5 24ths. Looks pretty good. Okay, so that would be finding the first 5 terms. Some of the homework tonight is going to be pretty easy. You're going to be plugging in some values and trying to evaluate what it's going to be. Now, one of the big patterns that we'll be seeing is this factorial pattern, okay? And we want to do a little bit of manipulation with factorials, and I'll show you kind of how some of those work with our manipulation. Let's say I gave you 5 24ths was 5. Let's say I gave you 10 factorial, and I divided that by 2 factorial, 8 factorial. Let's say I wanted to just work on some simplifying real quick here.
We multiply those two factorials together after you get the answer.
Oh, you could if you want. But we're not gonna quite go that hard. It looks big, hard, and nasty, right? If you put that on your calculator, it's probably gonna yell at you. It's probably gonna say overflow or can't handle it, right? 10 factorial is pretty big. I don't know if our calculator can do that.
Let me check it.
Yeah, check it real quick.
Yes, it can.
Can it? Sweet. Yeah, so what do we get? 3,628,800? That's 10 factorial. Numbers get really big really fast with those factorials, right? Another way to do this, though, is to just simplify with factorials. If you thought about 10 factorial and what that means we have 10 multiplied by 9, multiplied by 8, multiplied by 7, by 6, by 5. And I don't want to write them all out. It goes all the way down to 1, right? You guys okay with that? 2 factorial would be 2 times 1 multiplied by 8 factorial, which would be 8 times 7 times 6, blah, 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 right? We have a lot of canceling stuff. Cancel, right? Those parts of it cancel. From 8 below, those guys cancel. So we get a 90 on the top and a 2 on the bottom. So we get 45. So that guy should be 45. Yeah. Not bad, right? Okay, so we'll do a little bit of factorial simplifying. Now, I can get pretty evil on those guys. I can do 100 factorial divided by 3 factorial multiplied by 97 factorial. Now, put 100 factorial on your calculator, overflow, right? So your calculator will not let you do those, okay? It will yell at you. If you have a sign or a graphing one like this, it's under the math key, and then you scroll over 1 to the left or right, and then it's number 4. But anyways, 100 factorial, you could write this as 100 multiplied by 99 by 98. I'm going to cheat a little bit here. I'm going to write it like that. Is everybody okay with the way I wrote that?
Yeah.
Okay, did that clean it up a little bit? And the bottom is 3 times 2 times 1 multiplied by 97 factorial. Now the 97 factorials just cancel each other out. And so we have 100 multiplied by 99, 98. Divide those by 321 and see what you get. Now we can do a little simplifying on the way. 3 can cancel with 99 for, let's see, 3 goes in there 33 times, right? The 1 we don't need. The 2 goes into the 150 times. So 50 multiplied by 33 multiplied by 98, whatever we get there.
16170.
Was it that? Okay, cool. Sounds pretty good. Okay, so a little bit of factorial manipulation is good. Now let's go ahead and throw some letters in there. Let's do some simplifying with letters instead of just numbers.
So you don't, for that, you don't have to.
That's good. Okay, how about this? Let's go way harder.
Yeah, let's do it.
Let's do it. Go ahead and put that on your calculator. See what you get. Okay. I had a girl in geometry ask me where the X button was. In geometry. How do I put X on here? It wasn't a graphing one either. Like these actually have an X button, so it was one of the small ones. I gotta go check. Okay, now n factorial, n plus 1 factorial, let's just see what that means. Now, if we have n factorial, that means that when we simplify this, we're going to multiply n by whatever number is right before n. So we're going to take one number off of n. We're going to go n minus 1. And then we're going to go n minus 2.
Mine says domain error.
Good. Okay? So that's what you should get for n factorial. It's n multiplied by the number in front of it, by the number in front of it, the number in front of it. So we can take those numbers off every time. And then we'll divide that by n plus 1 factorial. Now, how a factorial works, you take the original number, n plus 1, and you multiply by one less number than that. So if I take 1 off that, that gives me n. Take 1 less off of that, gives me n minus 1.
Oh, so all those are going to cancel out.
N minus 2. Okay, so a lot of canceling going on. So what does this cancel to?
1 n plus
1 over n plus 1. Okay, so that simplifies to 1 over n plus 1. Okay, so that's not too bad. We got a lot of canceling going on here.
Let's get the n in the middle. Yeah, is that not supposed to be there?
No, that should be there. Technically, it should be n plus 0 if I really wanted to write it in there, but that's kind of overkill. For any time I have factorials like this 100 factorial, right? It's the number in front of it, which is 100, times 1 less than that, times 1 less than that, 1 less than that, all the way down, right?
Oh.
So n factorial, n plus 1 factorial, the number right in front of this, if I drop this by 1, if I take 1 away, gives me just n, because the 1 goes away. And then I take another 1 away, it gives me n minus 1. If I take another 1 away, n minus 2, n minus 3, n minus 4.
So like when you're doing factorials, like it just goes down to 0. So
Whenever it hits 1.
Okay.
1's the last number. If it went to 0, it'd just go away because you
Okay.
can't multiply by 0. But
So
it stops at
assuming
1.
that none of those, like, n can't be 2, for example. Because like n minus 2, then you're hitting 0
Oh, but
right there.
n can be 2 because if n were 2, I would have stopped right here,
Okay.
right? Because this would have been the 0 case. It would have been 2 times 1 times 0, right? So I wouldn't have even got that far if it were 2. Okay. So 1 plus n over 1 is your answer for that one. That's just a simplified for factorials. Let's go ahead and do what I think is the hard part for today. And that's figuring out your own a sub n terms for these guys. So let's do this one. Okay, I want to figure out what a sub n equals on this guy.
Wait, do we use that same formula too? The n squared?
No, sometimes factorials pop up, sometimes they won't. This one does not look like factorial. I would try to identify what you think the pattern is. You're adding 2, right? So isn't this arithmetic? So shouldn't we be able to write the equation real easy for this one, right? If it's plus 2, if your common difference is 2, because this is arithmetic, we can go 2n plus whatever number gets us to 5. 3. So 2n plus 3. So the apparent nth term, or the a sub n formula for that would be 2n plus 3. Okay, that's arithmetic. We've done that before, right? That's not too bad, I hope. Okay? Now, what if I gave you one like this? What if I gave you like 5, and then 15, and then 45?
That's geometric.
Geometric. So we've done this one before, so we know it's geometric. Identifying what it is at the beginning is good.
3. It's multiplied by 3.
So it's the first term, 5, multiplied by the ratio, which is 3. My r is 3 on this one. I'm going to multiply by 3 to the n minus 1. Okay? We did one like that in your homework. That's right. Okay, this is all stuff you've seen before, right? Now they're going to mix it all together, and sometimes they might even mix geometric and arithmetic together as well. So let me show you one where it'll be like that. Let's say I gave you 1 over 5, 7 over 15. No, yeah, 7 over 15. That's fine. And then 13 over 45. Fractions. Stinking. Now the nice part about this is I'm not adding from one number to the next the same thing all the time. However, if you look at just the numerators, what kind of sequence is the numerator? Arithmetic, right? Are we adding the same value every time, right? What about the denominator? Geometric, right? So we can have them mixed together. You just do them separately. So my a sub n formula is actually going to be some kind of fraction. I'm going to do my arithmetic on the top and my geometric on the bottom. So my arithmetic on the top would be a 6n minus 5. That would be the one on the top. That's arithmetic. The common difference is 6. And then negative 5 gets me to 1 if I were to plug in my top number. If I plugged in a 1 right there, 6 times 1 is 6, minus 5 is 1. So that got me to my first term. The numerators are arithmetic. So just like from yesterday, okay, numerators are arithmetic. The denominator is geometric though, right? Denominator is going to be 5, the first term, multiplied by the ratio, which is 3 to the n minus 1. So that's your a sub n formula for that. Sometimes they might mix those guys together, okay? So it's going to be kind of tough for you to identify which one is which, but they might put it into a fraction, and you might have separate ones going on here. Okay, what if I had something like this? Let's go even harder. Let's go 1/5 and negative 1/15 and positive 1/45. And then negative 1, what is that, 135? Is that what the next one would be?
It's like going forward and backwards.
It's geometric, yeah. They call it an alternating series for later on. Now, what some people like to do is they like to do the denominator separately. So they like to say, well, the denominator, I can see what the denominator is, right? It's geometric. It's 5 multiplied by 3 to the n minus 1, right? That would be our denominator. Now, our numerator is 1, and it's always 1, right? The only thing we have is we have a sign that's changing from positive to negative, right? Anytime you have a sign that's changing from positive to negative, what you do is you actually take -1 and you raise it to a power. And we're going to raise it to some power of n. So let's say we raise this to the n, how about a n plus 1 power? If I were to plug in a 1 right there, that would be a 2 in the exponent, and I would square -1. That would give me a positive first term, right? If I plugged in a 2, that would give me an odd number, making it -1. Okay? You can do n plus 3 there. Perfect. There's multiple answers. You can do n plus 3. You can do a lot of different options. As long as that's an odd power there, you're golden. Okay? Now that's if you want the odd. If you have an odd number here, then the even sequence would be negative on it. Anyways, so there's that. That'll get you a sign changer, which is kind of cool. What about some other exceptional ones? How about this? What if we don't recognize this one very well? How about, where am I at? Oh, that one, there it is. Okay, let's go ahead and write the nth term for this guy. I don't think we have time to get the recursive functions today. We might have to wrap it up tomorrow.
Oh, that's cool. Well, you multiply increasingly by 1 each time. How would you write it?
Yes, you do. How would you write it? Just a couple I need to cross off because we're not going to get to them. Okay, well first off we have a sign changer, right? It's changing sign, and we have a fraction, so we can do this. To go from here to here, you're multiplying by 3. Here to here, you're multiplying by 4. Right? Here to here, you're multiplying by 5. So we're multiplying by an increasing number every time, which sounds kind of familiar, like we just did that a second ago. Yeah, it's like a factorial or something, like that exclamation point, right? So we have to come up with some kind of exclamation point for this guy right here to get 2 factorial, 3 factorial, 4 factorial, 5 factorial. Okay? So if I plug in a sub 1, if I'm plugging in a 1 right there, I need to get a 2, right? So for me to get a 2 right there, and then the next one I need a 3, right? So my bottom factorial for this guy, I know I'm going to have some kind of factorial. And I need to add 1 to whatever my n value is. This is the first term, so I need to have n plus 1 right there. Now, it's always nice to double check after you're done. If you plug in for this n right here, if you plug in a 1, that gives you 2 on the bottom. 2 factorial is 2. If you plug in a 2, that gives you 3 on the bottom. That's 3 factorial. 4 factorial, 5, 6, all the way down the line. Okay? Now, we have a sign changer. Right, our signs are changing, so I need to have some kind of -1 raised to a power in the numerator. That'll make it an alternating series for me. So -1, raise it to the n power. Now, if I just left it as an n power right there, if I plugged in a 1 right there, that would make the first one negative, which is not, right? So I need to bump that by a power. So I'm going to put a +1 on the end there and call it good. It's either going to be an n or an n plus 1. It's going to be one of those two. If the first one's negative, it'll just be an n. If the second one's negative, it'll be an n plus 1. Like I said, you can put n plus 3 or n plus 5, whatever you want to on that. Okay? So that right there would be your a sub n formula for the sequence right here. Okay?
Wait, when is the n and when is the n plus 1?
Say it again.
When is the n and when is the n plus 1?
It's n if the first one's negative.
Okay.
Yep, I would go -1 to the n if we got a negative first term. I'm going to put just a negative a sub 1. You would go -1 to the n plus 1 if negative second term is negative, like so. Okay? So, on some of these, you just got to try to identify what the sequence is, what the pattern is, and then figure out which it falls in, which pattern it falls into. All right. So we're on 563. Would have been hard to do that first, right? Before you mentioned.
Yeah, that would have been kind of.
And we didn't even get there.
So there's 2 sides here, Mark?
You want to check? Yes. 1 and 2 to do that.
No, there's only 1 here.